we are going to record. So good afternoon, good morning, good evening to all of you, wherever you are. I'm Beth Zonas. I'm the Senior Director of Cleantech Open Northeast. And I am very pleased to have you all here to share in our excitement about the 2021 Cleantech Open Northeast Cohort. So without further ado, I am going to open my, I will share a screen here. Just give me one moment to set that up. And we will get rolling. Okay, so again, welcome everyone. I'm so excited that we are here for the 2021 Cleantech Open Northeast Regional Finals. First, I want to say this is an exciting event to celebrate all of the entrepreneurs in the 2021 Cleantech Open Northeast Cohort. They all deserve a hand for working really hard this summer and making significant progress with their ventures. Great job, everyone. It was a joy working with all of you. So congratulations. We can't say enough about our sponsors. Thank you for your generous support. You make what we do possible. And I want to also mention that we have 44 startups graduating from the accelerator in the Northeast this year. They represent 11 states, 1 territory, plus 6 foreign countries. Since we were all virtual this year, it was great to be able to work with startups from near and far. It is my pleasure to introduce you to my colleague. I want to just say, I want to introduce you to a couple of my colleagues today. Tally Kane is our Cleantech Open Northeast Regional Manager. And Tally, if you want to just wave and say hi. Tally is the brains behind a lot of what we do, and many of you have had the pleasure of meeting Tally. Tally, do you want to say a couple of things?
Hi, everyone. I just wanted to say that I am really proud of all of our startups and really happy to have been able to be involved for the entire accelerator, and I'm really excited for our regional finals.
Thanks, Tally. So we're going to run through a little bit here about our current cohort. We had 44 startups, as I said. They represented all these different areas. I also want to share with you a bit about all of the categories. Every single category in the Northeast, in the Cleantech Open has been represented in the cohort with some awesome solutions. So let's see. Last year, some of you may be familiar with this message. Last year, we conducted research on 15 years of Cleantech Open Northeast alumni. We found that 68% are currently active. They're generating over $279 million in annual revenue and have raised over $653 million. They employ over 3,300 people. Whoops, sorry about that. And they are increasingly diverse. We went from 47% to 63% of our founders being either women or people of color. And we're really proud of that. These numbers are continuing to improve each year, I have to say. So we look forward to seeing how the numbers look with the 2020 and the 2021 cohorts in the mix. So I do want to say, if you are inspired by what we do and you feel interested in giving, we would be very happy to take a contribution. We do depend on generosity to keep our program going. We have ambitious plans for improvement. And if you approve, please feel free to make a contribution here. It's maybe one of my colleagues can put the link in the chat here. It's tiny.cc/give-cleantechopenne. So thank you for that in advance. So what's new in 2021? Well, as all of you know, this has been a big year for diversity, equity, and inclusion. And Cleantech Open has embraced this topic in several ways. So we're working with an organization in the Boston area called Browning the Green Space and others to encourage our startups to incorporate diversity, equity, and inclusion into their ventures from the beginning. We're also building relationships with organizations that represent minority communities in order to make Cleantech Open more inclusive and diverse. We introduced programming to enable our startups to calculate their greenhouse gas emissions reduction potential. This exercise will help them all in conversations with investors that increasingly care about the environmental impacts of their solutions. So many of you know Ken Hayes. So Ken is the executive director for all of Cleantech Open. He's based in California. Ken has experience as a venture capital and angel investor, and he is, as he says, a recovering entrepreneur who has built and sold several companies in Europe and the US. So I'll turn it over to you, Ken, to make some remarks. I can stop sharing for a moment.
Hi, Beth. Thank you so much. It's great to see so many people on the line here today. And as Beth says, yes, I am based in California, sunny California. And we just finished running the regional finals for the West and the central and the regions in the central part of the country with, I think we had 63 companies go through that. And they're all excited to go head to head against the companies out of the Northeast here in a few weeks at the Global Forum event, which all of you are invited to. It's free. It'll be on Zoom. It's October 20th to the 22nd. So we'll put a link in the chat. You're all invited to that. And that will also be a very exciting event. Thank you to Beth Zonas. Really, Beth, you've done a remarkable job with the team that you lead in Cleantech Open Northeast. Thank you to Tally, who you've correctly recognized as being a really, really accomplished and improving and better addition to the team. Phoebe, Cassia, Katie, who've also been part of it. So, the Northeast region is very strong and dynamic and does a lot of pilot initiatives, as Beth gave a couple of examples. And that's a really good example for the rest of the country. Speaking of which, Cleantech Open this year, our cohort was 20% larger than last year. The interesting thing about the pandemic and moving our operations online was that more companies and entrepreneurs got an opportunity to really level up their skills and become better entrepreneurs within our sectors of clean tech and climate tech. We had a 93% completion rate for companies graduating the accelerator of those who started, and that's also higher than has been in recent memory. And the result of that is we're going to have 104 startups at our Investor and Partner Connect event. That's coming up in a couple of weeks, October 12th through the 14th. We have to spread it out over 3 days to give our investors and corporate partners and others like MassCC, NYSERDA an opportunity to meet as many of those companies as possible. And if you're in that category of actively deploying funds and evaluating companies like this in the early stage, we would love to have you join. You can reach out to me or Beth for an invitation. So that's also going to be really wild. It's on Zoom. There's a lot of maneuvering behind the scenes to make that happen. And it works out really, really well. This is also an exciting time for Cleantech in general. Yesterday, I had the privilege of being on a roundtable discussion organized by Lacey, the LA Cleantech Incubator, where they have engaged along with others in our ecosystem, and NECEC is also part of this, to lobby for additional funding for our ecosystem. And there are initiatives both in the infrastructure bills and Build Back Better to really improve funding for our ecosystem. So there's some really exciting times ahead in Cleantech. So with that, I want to introduce the head of NECEC, Peter Rothstein, who I've had the privilege of working together with for 4 years since I started at Cleantech Open. He's been involved with Cleantech Open longer than I have, sat on the board of directors, And I've always been impressed at how Peter has stewarded and grown NECEC and really assembled a great team and been a loyal supporter of Cleantech Open and really made sure that the resources were available to the Northeast affiliate, which Beth runs. And so for that, Peter, I very much appreciate your support. And I'll let you continue your remarks. You have some other adventures ahead. And thank you again for being part of Cleantech Open.
Thank you very much, Ken, and congratulations to you and the whole National Cleantech Open organization. I'm Peter Rothstein, as was said, president of NECEC, and I'm really pleased to be part of this convening today. And congratulations to all of the startups. You guys have been doing great work. And also thank you to all of our judges and mentors and sponsors. They all contribute so much. I'm really looking forward to seeing the finals presentations coming up soon. Just a quick word on NECEC. We're here because Cleantech Open Northeast is in effect sort of a joint venture between the Cleantech Open national organization and NECEC on the Northeast, where both Beth and Tally are part of our team and are connected. NECEC is all about helping to grow the clean energy industry, the clean energy economy of the Northeast, particularly New York and the 6 New England states in combination. And a big part of growing the clean energy industry and the clean energy economy is innovation. It's about supporting startups. It's about the innovation ecosystem that is there to find partnerships, to find investors, to find collaborators and strategic partners. All of that is a big part of what NECEC works to convene, to help grow, and to help create markets for here in the Northeast, where there's some great opportunities for clean energy deployment as well. So that's all part of what NECEC is about. And Cleantech Open has been a natural partner for us for many years, and it's great to see it continuing. So thank you, Ken. Thanks, Beth, and congratulations. And I actually want to introduce two of the Cleantech Open Northeast major sponsors and partners, one at a time. But I'll start with Jen Delocio, who's the interim CEO at the Massachusetts Clean Energy Center, MassCEC. Jen leads MassCEC's efforts to build a robust, internationally competitive clean energy economy in Massachusetts. Jen has been part of MassCEC as the Chief Financial Officer and Treasurer since November of 2014, recently stepping up into the interim CEO role as well. So she brings a wide variety of finance, information technology, and HR and operations experience to this role, and really leading MassCEC, who is who's an amazingly important supporter of the clean energy sector in the Commonwealth of Massachusetts. And so Jen's up on the screen. Jen, I want to give you the floor and turn it over to you for a second.
Great, thank you, Peter, for the introduction. I'm so happy to be here today to kick off this year's Cleantech Open Northeast Regional Finals. I want to thank Beth and the team at Cleantech Open Northeast, as well as Peter and the team at NECEC for their hard work in pulling together this year's program. Cleantech Open Northeast has been an invaluable partner in driving research, innovation, and economic development, not just in Massachusetts, but in the entire region. I want to extend a warm congratulations to all of the startups today, and also those selected to pitch in this year's regional finals. At MassCEC, we're focused on helping to grow the clean energy industry in Massachusetts while helping to meet the state to meet its climate goals. A big part of what we do at MassCEC is focused on supporting innovation, technology development, and commercialization. We're always interested in learning about new technologies, hearing from the industry about market challenges, and spending time connecting entrepreneurs to customers, investors, and strategic partners. Days like today, where I get to hear your innovative ideas and see your enthusiasm, are one of the best parts of my job. But it's really seeing you succeed that inspires my colleagues and me every day. And to be honest, your success is critical now more than ever. As you might know, Massachusetts has set ambitious climate goals, which include achieving a target of net zero emissions by 2050. Innovative technologies and approaches to decarbonization can help us achieve those goals at a faster pace and a lower cost. We need innovation that's disruptive, shaking up markets and creating exciting new solutions. But we also need incremental innovation, the kind that increases performance and decreases cost. The shift to a low carbon economy is not easy, but it will open up thousands of opportunities for startups like yours. And that's why MassCEC has been proud to support Cleantech Open since 2011. Since then, we've awarded 49 graduate companies with funding of over $8.5 million. At MassCEC, we have a suite of technology development and investment programs to provide funding to innovators. In the last 10 years, MassCEC has provided over $128 million in funding for technology, innovation, and company growth. We've seen the success of these graduate companies, a testament to the hard work and dedication of those entrepreneurs, their mentors, investors, and the confidence of their early customers. Programming from Cleantech Open, with its dedicated community of mentors and advisors, provides a strong foundation for startups to succeed. Our work is more urgent than ever. To meet our goals, we'll need solutions to decarbonize our buildings. We'll need to dramatically increase the number of electric vehicles on the road. And we'll need an electric grid that can meet the needs of a net zero future. And that's just a simplistic overview of the many challenges that lie ahead. But clean energy startups like yours are driving this change, and it's happening at unprecedented levels. As a Cleantech Open graduate, I encourage you to reach out to policymakers and organizations like MassCEC. We need to hear from you on the policies and laws that are critical for your success. And most importantly, we need you to carry on with your groundbreaking and innovative work. Congratulations to all of the startups, and best of luck to the 6 competing today in the finals. We look forward to seeing all of your future successes. Thank you.
Thank you, Jen, and thanks MassCEC across the board for the role you play and the support you provide to clean energy and the clean economy growth. And now I want to introduce another champion and great supporter for clean energy, and that's Doreen Harris, who's the president and CEO of NYSERDA, the New York State's Energy Research Development Authority. Doreen has been the president and CEO of NYSERDA since April of 2021, although she was in the acting president and CEO role starting in June of 2020. NYSERDA is a very important agency in New York. It's a public benefit corporation that advances innovative energy solutions to improve New York State's economy and environment. Doreen has held public and private sector leadership roles in clean energy and engineering for more than 20 years. Including some previous roles at NYSERDA as Vice President of Large Scale Renewables and leading the effort to spearhead development of the offshore wind sector in New York. NYSERDA in many ways, in many similar ways to MassCEC, is really a driver and supporter of the innovation ecosystem, the clean energy innovation ecosystem in New York State. And NYSERDA is a great partner to the kind of startups coming up through Cleantech Open, especially as they grow and scale and look to deploy. So Doreen, why don't you take it away? Thanks for being here.
Yes, thank you, and good afternoon, everyone. Peter, thank you for your kind introduction, and great to see everyone here today, including, of course, my colleagues from the MassCEC. It's such a pleasure to be here to kick off the Cleantech Open Northeast Regional Finals. What a thrill. It has been amazing to see where we are now with the Cleantech Open Cohort that has brought together companies from around the world. Notably, as we just saw, from Ethiopia and Europe and to Thailand. And I am very pleased to share 9 companies that are based here in New York State. So regardless of where you all hail from, we are certainly thankful that you have dedicated your time, talent, and treasure to what we believe is one of the most exciting missions available, charting a course to a clean energy future. NYSERDA and I am a proud supporter of the Cleantech Open Northeast because we know this accelerator is helping to develop the cutting edge innovation needed to reduce the impact of climate change and bring us to new heights of decarbonization. Clearly, the devastating impacts of climate change are being seen around the world, from flooding to wildfires and severe droughts. And the recent impact report from the International Panel on Climate Change makes it clear that we need to take swift action now to set the stage for a more resilient future together. And so we in New York have taken an all of the above and an accelerated approach to realizing these outcomes by driving the economy-wide transition needed to support a green economy, create green jobs, and deliver the technology, innovation, and adoption that is needed to help consumers reduce their carbon footprint. NYSERDA's innovation investments alone have generated more than $780 million in private investments, while bringing more than 440 new and improved clean energy products to market, including LED lighting systems, home appliances, longer lasting batteries, and more efficient heating and cooling systems, just to name a few. But to be clear, we are exploring all technologies and solutions in our work, including the areas of renewable energy, building technology, energy storage, energy efficiency, and transportation. And that is what makes your participation in Cleantech Open Northeast so exciting. You, as we speak today, are bringing forth the next generations of clean energy solutions, history in the making, if you will. And as you continue forward in your clean tech journey, I encourage you to tap into all of New York State and NYSERDA's additional resources for entrepreneurial and startup support. We have 6 NYSERDA-funded incubator programs, an entrepreneur in residence program, 2 statewide accelerators, and Scale for Climate Tech, which supports businesses with manufacturing scale up, and many other programs as well. Additionally, the New York Green Bank, a division of NYSERDA, is part of our portfolio, offering financing for clean energy and sustainable infrastructure projects, helping to accelerate deployment and enable emerging business models. So to explore a full list of programs, certainly visit our website at nyserda.ny.gov. And I encourage you to reach out directly, including to me. Public-private partnerships have been the cornerstone of our success to date, and even more so in the future. We welcome the chance to talk to you about building the best climate tech ecosystem in the world and delivering a just, equitable transition to carbon neutrality that benefits everyone. So thanks again for inviting me today. I wish you all the best of luck in the competition.
Thank you very much, Ken and Peter and Jen and Doreen. Really great to hear from you and get your perspectives on the work that we're doing. So without further ado, I will continue my little slide presentation, and then I know you're all really eager to hear the presentations, but we're not there yet. We're almost there. But we have a couple of things that we wanted to share with you first. So the first is, I want to share our mentors of the year. The first one is Sheikh Drameh. Not sure if he's here today, but this is his second year as a mentor with us. He was lead mentor to VoltPost. He's active on our mentor committee. He even recruited a colleague to participate as a mentor this year. Sheikh is a dedicated and enthusiastic mentor. He is always willing to speak with entrepreneurs. His team said, Sheikh led the mentor team with transparency and respect. His experience at National Grid adds a unique and vital perspective to VoltPost. Thank you, Sheikh. Barbara Bat-Shalom has been a sustainability mentor with us since 2018. She mentored Hydronic Shell this year. Her team said, Barbara was highly engaged with us throughout the program. She never missed a meeting and always gave us thoughtful and helpful feedback. She also gave us time outside of the weekly meetings to dig deeper into some topics. She has a lot of experience in the world of construction and architecture and helped us make a number of valuable connections. Overall, she was super nice and very fun to work with, and I really can't say enough great things about her. So thank you, Barbara. Pam Reed is a first-time mentor this year. She mentored Moduli. Pam attended almost all of our events this year. She stepped up to take a leadership role with the team that she was assigned to, adding a lot of value to the process, not only for her team, but also for others in the cohort. Her team, Moduli, was just recently accepted into Techstars Alabama. So congrats to Moduli. Cordula Schmidt. is another first-time mentor this year. She mentored Sithan. Her team said, Cordula has been very supportive and very proactive in responding to my technical needs and providing many contacts to support my technical development in the US as part of the company's development strategy. So I want to say our program runs on mentoring. So the mentors are absolutely essential, and I want to applaud all of the mentors and especially the 4 that we are honoring today. So thank you all. And it is my distinct honor to give the Lifetime Achievement Award to our very own Peter Rothstein. He is retiring this year after 11 years leading NECEC. He was instrumental in bringing Cleantech Open into the NECEC family in 2011. And this is a partnership that continues to grow stronger. Good luck in your retirement, Peter. And thank you very much for your leadership.
Thank you, Beth. Much appreciated, and a surprise on my end. But retirement means I could probably be even more involved next year, right?
There you go, perhaps. And then now it is my distinct pleasure, and thank you again, Peter. It is my distinct pleasure to welcome our judges. And we're going to get going with the program momentarily. But thank you all for dedicating your time and expertise today. We really appreciate it. All of our judges are experienced clean tech and climate tech investors. They are joining us from near and far. Brandon Blesser with Ecosystem Integrity Fund in New York, Alba Forens with Seeds Renewables in Spain, Jing Ge with Vectors Angel in California, Dan Goldman with Clean Energy Ventures in Massachusetts, Neka Uzo Kibule, I hope I'm pronouncing that right, of Aligned Climate Capital and also Green Tech Noir in California, Daniela Vargas with Social Capital in Mexico, who's actually joining us today from France, and Adam Wallen with Breakthrough Energy Ventures in Massachusetts. So thank you all. Okay, now, before we call up the first startup, I do want to make sure you're all aware that there will be a People's Choice Award at the end of all of the pitches. So all audience members will be able to vote. So make sure to stick around, listen carefully, and decide whom you like best. After today's pitches, we will have 4 regional winners selected and 1 carbon sequestration prize winner. And that notice will go out tomorrow in various ways. So first, we're going to hear from measured air performance, and then after that, we go in alphabetical order. And let me just make sure that, yeah, that's it. So we're going to hear, I'm going to stop sharing, and Tally's going to start timing, and we're going to get going with measured air performance whenever you are ready. And
let me see, I've got to get my screen sharing going. Hold on one second.
You're on.
1 second.
Okay, absolutely.
I messed up when you, what's going on? Hold on a second. I just lost my screen sharing ability. This is not good.
Okay, so what you need to do is go to the bottom where it says share screen.
There we go. There we got it. Yeah, I was in the wrong area. No problem. There we got it.
Okay.
So you guys can see that now. Is that correct?
Yes.
Full screen, and we're ready to go.
Go.
We are ready.
You're ready.
So I'm going to talk about laboratories. They are very, very big energy users. Most of them have very aggressive carbon and energy saving goals, but the technologies and the ability to save energy is becoming somewhat asymptotic, and that's where we come in. When I say they use a lot of energy, lab buildings, a typical lab building uses conservatively as much energy as 200 residential homes. The reason is that the air is assumed to be contaminated potentially, both the exhaust and the air in the lab room, so they need to blow a lot of air through. They use 8 to 10 times more than a commercial building, so it is a tremendous amount of energy. But where the opportunity is, the left is the basic assumption that labs are always in use. The reality is they're not. I'm at a conference on labs and fume hoods, and I talked to one of the top consulting firms. They said lab activity is around 10 to 15%. So if you can crack the code on when labs are active and inactive, when the air is clean and when it's not, there's a huge opportunity for energy savings. So here's a very sophisticated schematic of lab exhaust system. It starts with a fume hood. I think most of you remember from college. It's that big box that you do work with, mixing compounds. Some of them are toxic. And what it does is that has perpetual negative pressure. It's always drawing air in so that if you spill something toxic when you're working with it, or a researcher is, it'll pull it away from you. The bad news with that is it's using conditioned air. So it's been heated, cooled, dehumidified once, and it goes right up there to keep you safe. At the other end is a thing called a high dilution lab exhaust fan. It's got two functions in life. It's got to create a high plume, 60 to 70 feet in the air, to dilute any potential contaminants in it, make sure they don't get sucked back into the building. What's interesting is if that fan is running at this high speed, it might need to draw, for example, 100,000 CFM of air. But if your lab only needs to exhaust like 70,000, it can't pull it through the lab. So what it does is it has these dampers on the roof, and it pulls that extra 30,000 CFM of air so they can run at that high speed, create that great big plume. But again, that air is clean 80 to 90% of the time. So why are you running these fans at these high exit velocities when there's nothing to dilute? And that is our first product. It's commercially available now. It's called SmartStack. Monitors the contaminant level of lab exhaust air. And when the air is free of contaminants, we basically tell the building automation system, hey, stop drawing all that air off the roof. And all you need to do is exhaust air from the lab. So there's a tremendous amount of opportunity for electric savings. I've got the little brain there because we've got an outstanding patent. Our patents are not around sensors. They're about the information those sensors provide and how that information is utilized. So now we're looking at the other end where there's greater savings, right? You've got heating and cooling at the other end when you're talking about conditioned air. So the product that we currently have in development is called SetSafe. And what it does is it monitors multiple points, which I'm going to talk about in a second. And when the criteria for inactivity is met, we're saying, gosh, yeah, when you close that sash, that door, you can lower airflow. But boy, if there's nothing going on and the hood is empty, why don't you either turn it off or turn it down even significantly more? And the savings can be really significant. Again, we've got a patent pending on that. It is not about the sensors. We're using commercially available sensors with some modifications. It's about the data that sensor provide, or those sensors provide, and how we can leverage it to save energy. A little technical, but basically these are the parameters that we're looking at to ensure that a fume hood is what we call inactive. You want to make sure the door is closed. You want to make sure there's not beakers of volatile compounds in there. You want to make sure there's not a Bunsen burner on, a heat plant, a magnetic stir. You also want to make sure there's nobody there. So we can take all this information. And also we want to look at history. We want to make sure somebody's not standing in front of it or it was just there. But when the criteria is met, we can lower it. And we will also have the ability to look at trends. We do a lot of work with the University of New Hampshire, and one of the facility managers is saying, what we like about your concept, Steve, is we've got a lab that's used second semester of the year. It's used 2 hours twice a week. So why am I running these hoods at higher air volumes than I need to? So real big opportunity for savings. The market is substantial. There is 1.2 million hoods install base in the United States. The new installations, 20,000 to 25,000 get installed new each year. We're looking at selling this product approximately at $2,600 per fume hood. Install cost all in commissioned is probably about $5,000. The projected savings for this is between $1,500 and $2,000 per fume hood. So you're looking at about a 3-year or less payback. But we also know there's a lot of rebate money out there. We're already talking to some of the utilities for prescriptive rebates to say that rather than do the math on what the savings are per fume hood, we're going to give you X amount of $1,000 per fume hood for every one that you're installed on. And we see the business cases likely being under 2 years for this product. Everybody's competition. What we're doing is pretty new, but right now the effort is closing that sash because you do lower flows to a certain degree. There are products like automatic sash closers. The one in the center on the bottom is an occupancy sensor, which is, okay, nobody's in front of this fume hood. Why don't we lower the flows and save energy? The guy on the top pulling his hair out is based on a conversation I had about a month ago with a Big Ten school. The individual said, yeah, I've got a 10-page procedure I can go through to hibernate my hoods or turn them off, which a lot of universities want to do. And he says, not worth it. I'll just keep them running through Christmas and April vacation because it's just too much work. The last one is signage, really effective for researchers not to forget as they leave their hood for the night to close the sashes. But what's great is we essentially leverage the stuff. I mean, you want that data. The sashes have to be closed to really lower the flows and before we can really take them to the next level. So we actually leverage a lot of the existing competition. Here's some projections. I like to say that sales projections were invented to make weathermen look good, but The important things to take away from this is a couple. One is current product has got a recurring revenue stream of about 10% of revenue. Margins are very much like software, although it's a hardware solution, they're in the 70%. Pending product, again, somewhat similar margins, not quite as high, but close. And I'm really, really big on either recurring revenue or additional sales for services. Warranties for me, if you build a good product, are free money. We're looking at a service plan where you can have silver service, means you can call us between 8 and 5 in the day for any problems. The platinum would be 24-hour-a-day service. So that's what we're looking at from the revenue side. Again, I've touched on the margins. For me, we're actually not looking for money right now. We may be in the future, but we're not quite ready. But I'm projecting an EBITDA of 3.7 million in 5 years. Companies like ours sell typically for 6 to 10 times EBITDA. So if I were raising money, my starting point would be some multiple between there with an EBITDA of about 3.7 and kind of negotiating from there regarding equity. But again, very conservative. I know some people will give me grief that it's not aggressive enough. This is labs, it's safety, it's not a quick sale. I hope we crush that number, but I think that's a very realistic and achievable number. And again, I think we have the opportunity to really crush that number. Just about the team, a couple important things. Our CTO is arguably one of the top guys in the country when it comes to sensing and ventilation in labs. He was involved with starting a company called Phoenix Controls, and that was eventually acquired by Honeywell. He essentially developed their initial product line. He then started a company called Aircuity, which does really good work in demand control, ventilation, lowering air change rates in labs. Helped found that company and created just a great company and developed a product line. I was involved with the company on the verge of bankruptcy. I got involved with it. Over a few years, I took sales up by about a factor of 4. We had a couple buyers to the table. We didn't sell the company, but the money wasn't quite what the owners want, but it was close. So I think we're both well positioned to take this company to the next level and eventually sell it. The exit for us is we're a really good fit with the big controls companies, the Johnsons, the Siemens, the Honeywells, and the Schneider Electrics. They frequently, we're the ideal company. We find a new opportunity, we build the product, we get patent protection on it, seed the market, build the market, build sort of a nice base and get it institutionalized in the market. And then again, they'll write checks to companies for us that are rounding errors in their checkbook, but they're very meaningful to us. And I think I finished a little bit early, but that was it.
Great. Tally?
Okay, great. So startups or judges, go ahead and start questions.
Steven, quick question here. Daniela over at Social Capital. What is the average lead time for a new sale?
Our sales cycle, it can be anywhere from, for retrofit, it can be 6 months. For new construction, it can be 18 to 24 months. You know, you're up real early with these engineering firms, and it can be a two-year. So our initial focus for this product, we launched in 2019, has been retrofits, and we're literally just now starting to get new construction.
Thank you.
Thank you, Stephen, for your presentation. This is NECA. I had a question around your recurring revenue that you're expecting. What's the opportunity costs for the O&M, and how much are they typically paying for support services right now?
So on our existing product or the pending product?
For the competitor, the status quo.
Well, right now for fumage, it's a good question. These, but they're almost like gadgets. Like the automatic sash closer is a relatively low cost item. It's really insignificant. It's insignificant. Again, you're buying a device. It's got a little sensor and it pushes the door down when it doesn't feel any pressure on it. So relatively inexpensive.
Okay. Thank you.
Adam Wallen here. Thanks for that. Just a question: who installs? Is that your own group? No,
we train. We're hardware manufacturer right now. Like with SmartStack, we've done projects with Siemens, JCI, Schneider Electric are the ones that they basically, you know, we'll coordinate and help with the control sequence. But they're the ones that contract out. And what's great, it's a rifle shot. You know, our installation on SmartStack, it's like it mounts on Unistrut in the penthouse, runs off 120 volt power, which we step down. So it's half a day installation. The controls work. Well, now what's great with like Siemens, I just say, for a guy in California, call the guy in Boston, he'll just tell you what the control sequence is. So it's becoming pretty easy, pretty rapid installation.
Thank you, Steve.
This is Brandon from Ecosystem. How are you going to hit the whole country quickly? And who are you really selling to? Is it the building manager or?
Yep, good question. Tentatively, I think we're going to go with our existing rep network. So we've got a rep network that is selling our current product, SmartStat. So that would be our approach. They've got the relationships. There's like no way. I mean, that number, I'd be asking for like $5 million if we're going to go with a direct sales force, as much as I would like one. So we'd use the existing rep network, which is great because it's the alcohol labs. I'm sorry, the second question was, who do we sell to? We sell to tons of people. Retrofits, it's the facility team. They may have an energy manager involved. And for new construction, we call on BR+A, Vanderweil, AEI, we call on all the engineers. We also call on a lot of the commissioning firms and energy assessment firms, because this is an upsell for them. They can go in and say, hey, by the way, you want to see some energy? I know a company that has this product. Then they install it, they get the commissioning money, they get to manage the some of the installation process. So we sell at multiple levels, but new construction, it's the owners and the engineers. Retrofits, it tends to be more the facility manager and the energy managers.
And what were those
Great.
margins?
Thank you, judges.
Never mind.
All right, so judges, you have 2 minutes to finish your scoring sheet. Next up, we will have InfoSense. So please set up and you can begin sharing your screen if you would like.
Hey, Tally, mic check. Can you hear me there?
Yes, we can hear you loud and clear. And we can see your screen.
Okay. Thank you.
Mm-hmm.
While we are waiting, I just wanted to make a quick comment to the judges. So it would be great if you could raise your hand and we'll call on you if you have a question. That's a little bit more organized. Thanks. If you are wondering what I'm talking about, you go to the bottom right of your Zoom screen and you'll see a little button that says reactions. Just click on that and it says raise hand. And then when you're done, you can actually hit another button that says lower hand.
All right, judges, we are getting set up for InfoSense to begin their presentation. Everybody ready? Set, and floor is yours, Tim.
Tens of thousands of years, humans have developed, refined, and perfected ways of nourishing and sheltering our communities. We have evolved from ancient terraces and floodplains that support small villages to massive industrial farms that feed billions. We began by designing shelter that worked in local conditions and now can build extravagant cities in nearly every environment. So how did we do this? We compiled a trove of knowledge from thousands of years of monitoring, analyzing, and optimizing the world around us. We developed a massive collective data set, which informs how to grow food and how to shelter our people. So what are we supposed to do when all the underlying assumptions, data sets, and collective wisdom come crashing down? When the land we depend on for food is too hot, too dry, too wet, pushing us to grow more indoors? When the air we breathe outside or inside of our homes and buildings can make us sick or even kill us? The urgent question today is, how do we obtain 10,000 years of collective knowledge in one generation? The answer is data. If we are going to grow more and more food indoors, then we need to monitor, analyze, and optimize how plants interact with their surroundings. If we are going to decarbonize our buildings and make them healthy, resilient, and regenerative, we need to know exactly how they respond to changing weather, how, when, and why they use energy, when they are being occupied, and whether or not the air is safe to breathe. So we need to monitor, analyze, and optimize the world around us. But doing this has been difficult, expensive, unreliable, and in many cases, impossible. The experts with the skills to tackle these challenges simply can't get the data they need. Well, InfoSense changes all that. We make it possible to put a sensor in nearly any environment, on any point in the planet, and get that data easily to the experts that need it. We leverage an open ecosystem of long-range wireless sensors that have the superpowers the world needs today. The ability to send data for miles, communicate reliably deep indoors and outdoors, and last for years on a single battery. And we make it all work like magic with software that provides clean, consistent, and actionable data. So let me walk you through 2 examples of how our customers are using data to tackle the world's most pressing problems. In the indoor ag market, our customers are using wireless sensors to obtain high-density microclimate data above and below plant canopies. They identify issues, optimize yield, and reduce the energy and water required to grow more. They are increasing yields by 5 to 15%, generating multi-million-dollar returns for growers. And we are unique in that we're very intentionally not going direct to the growers. Instead, at this stage, we are powering leading platforms that combine InfoSense's data with cultivation expertise, analytics, and machine learning. And they are expanding to serve growers from Canada to the Caribbean and Massachusetts to California. Now let's take another example of some work our customers are doing in the building space. So the grid is changing right before our eyes. On the demand side, everything is being electrified. And on the supply side, renewables are flooding the grid during the day, causing dramatic swings in the evenings when they go offline. And our buildings now need to become interactive virtual power plants. Yet grid operators and utilities simply don't have the data to understand how all of this works together. So as we speak, leading energy firms are using InfoSense's sensors and data to monitor exactly how and when electric heat pumps are being used across hundreds of sites throughout the Northeast, so grid operators can have accurate load forecasts. Another leading firm has deployed InfoSense in hundreds of homes and businesses across Brooklyn and Queens to monitor the impact of retrofits on New York City's grid. We've made it so easy for these companies to obtain data from hard to reach places so they can go focus on what they do best and build the interactive zero carbon grid of the future. And we have validated our product market fit. We have posted impressive revenue earnings and established MRR. With a team of only 2 people and launching right before the pandemic, our customers went on to reach over 500 unique sites throughout North America, including commercial, residential, agricultural, and industrial facilities. We have established beachheads in each of these 2 markets, and now we're ready to move inland. We have targeted expert businesses that land and expand, and we have built the infrastructure that simplifies a complex wireless sensing ecosystem. So now we get to build on top of that, provide deeper solutions that respond to market demand, such as HVAC monitoring, demand response applications, indoor air quality, and carbon accounting and ESG reporting. Our solutions cross-cut both of these beachhead markets and more. As one example, did you know that 90% of buildings in the US are both under 50,000 square feet and do not have a centralized way to monitor their rooftop HVAC systems? To date, that has been technically and financially impossible to do so, but we are developing a solution that can do this for under $100 a year, and penetration of only 1% of all rooftop systems can net $10 million in ARR. The applications for this long-range LoRa technology that we use represent over $64 billion of addressable markets, from terrestrial all the way into space. Smart devices can be deployed to monitor equipment, predict issues, warn of problems, and reduce the need for humans in remote or dangerous places. Now, this is where our story takes a very exciting twist. So what you're looking at here is a map of New York City. And every one of these green dots on the map represents a physical piece of hardware. It's a gateway, also called a hotspot. And now these are not Wi-Fi hotspots, but each one of them is providing miles of coverage specifically for long-range LoRa sensors. So that's the same wireless protocol that we have built our entire company around. And now it's exploded onto the scene and is nearly ubiquitous in every major city in the US. So how did this happen? Well, a company and a close partner of ours called Helium created an innovative model that incentivizes individuals to buy and place these hotspots in windows and on rooftops, and then rewards them with cryptocurrency tokens for providing network coverage and transferring LoRa sensor data. And this is not Bitcoin. Each hotspot uses the same amount of energy as an LED light bulb. But it's gotten crazy because when we applied for CTO, the Cleantech Open, there were only 30,000 of these online. Today, there are over 200,000. The growth is on fire, and a recent investment of over $110 million by Andreessen Horowitz validates the massive growth opportunity in this space. And immediately, it means three things for InfoSense. First, because network coverage is becoming ubiquitous, we can now provide sensors to our customers at a 10x reduction in upfront costs, breaking down old barriers to scale. Second, if coverage doesn't exist, we can own and deploy these hotspots, support our customers' sensing needs, and generate recurring revenue off of those. Finally, the value of this entire network depends on using it for sensing data, and Helium needs InfoSense. And in fact, multiple C-suite executives at Helium personally supported our fundraising round and stating, quote, InfoSense is one of the scrappiest companies in the LoRa ecosystem, and what they are doing is completely unique in this space. Now, when we applied to the Cleantech Open in April, we were only a team of 2. Now we have assembled a powerhouse team of 7 experts with deep backgrounds in connected devices, energy markets, precision ag, and controls and instrumentation. We know exactly where we need to fill gaps, and we're focused on diversifying our team. We've also started with a small but impressive advisory board. Now, how do we make money? We sell data. We sell real-time data feeds. So our customers install wireless sensors and pay us to ensure the data is always there. We also resell LoRa sensors and hotspots and mark those up. But the data we provide and the data sets we're amassing are exponentially valuable, and we plan to monetize that in multiple ways. We also know our competition cold because we've lived this pain in the field. We have used it all ourselves. And we know that unlike our competitors' hardware-first proprietary approaches and difficult to scale one sensor equals one app models, our focus on data for cross-cutting use cases makes engineers and analysts love us. Now, we raised $750,000 this spring, and we immediately expanded our team to support our growing customer base. But now we are seeking $3 million so we can move fast and smart over the next 1 to 2 years. The disruptive viral explosion of Helium validates everything we've worked on since our inception. And we find ourselves in the pole position. And this round can bring billion-dollar products to the market. We just need to hit go. Now, when it comes to exits, right now we are focused on creating a great company with strong cash flow. However, we see many examples of 5 to 10x acquisitions in this space. We also believe with the explosive growth in the LoRa ecosystem, that consolidation up and down the stack is likely to occur in the next 3 years. We also know that the highest likelihood of acquisition is from a partner. And to that end, we are working on partnerships with companies that have made acquisitions in the buildings and control space within the LoRa ecosystem, and more generally in the Internet of Things space. Thank you.
Thank you, InfoSense, for a great presentation. Judges, any questions?
Yeah, judges, if you could raise your hand if you have a question, and if I don't see you, just blurt it out. Oops, I see a hand. Okay, wait a minute. Go ahead.
Yeah, hi, it's Dan Goldman.
Dan, go ahead.
Thanks for that presentation. I'm just wondering, like, is there any intellectual property or sustainable competitive advantage that you have in this? Because I mean, data businesses are notoriously hard to protect, and with competition, it tends to compress margins.
Mm-hmm. So the complexity of this ecosystem led us to develop the infrastructure plus an API, right? The interface to get the data to serve the customers in the way they need it. And what that's allowed us to do is serve multiple cross-cutting use cases while searching for particular solutions that can both enhance our customers now and go even beyond to the end users that they'll never potentially serve. So expand our markets, and that's our IP strategy, is to develop those solutions that take sensors to solutions and put that in place around that.
Cool. Alba, you're next.
Great, thank you. First of all, thank you, team, for your presentation. It was very interesting. And well, my question is more about the installation and the maintenance of your sensors. Do you also install them and make sure that they function well, or are you only involved with the data?
So we support it all, but we've actually, and we say this often, those 500 plus sites that we got to, we didn't have to install any of those sensors. So we're selling to experts in our current go-to-market. They are purchasing the devices and installing them themselves. If for any reason they need some supporting role in a local site, we have large networks of contractors and technical folks that can be pulled in. But they are generally handling that work. And then we support them with data, SLAs, and support along the way, including interactions with manufacturers if things needed to be, dealt with or troubleshooted.
Thanks.
Great. So Brandon, you're next.
Curious, Tim, if you sort of explored the command control bi-directional solutions, because often data is the first step towards, realizing an ROI.
Right.
Any examples there?
Right. So yeah, so we're very focused on data now, because when you get into controls, you have to do that very carefully, because now you are wedded into a particular site, a particular piece of equipment, and there's a different kind of interaction there, and it's harder to scale earlier on. So we've gone for scale and the data first, but a couple examples where we're going. One is many of our customers are doing what we think is the modern way: an independent data layer, data monitor, independent data layer, supervisory control using software to control equipment and things. And we're very much purpose-built for that. Second, the newest addition to our team is a deep controls and instrumentation expert. And that's allowing us to kind of go deeper into that while knowing exactly the ramifications and implications of doing that. So we can provide things like demand response strategies or support those efforts using this open LoRa ecosystem.
Thanks, judges. You have 2 minutes to finish your scoring sheet. Next up, we have Innovia Geo. So please feel free to set up and begin sharing your screen for a technical test. We can see your screen.
Great. Can you hear me okay as well?
Yes.
Thank you.
So for anybody who just joined, we are in between presentations, and we will get into Innovia Geo shortly.
All right, judges, it is time for Andrew Lee of Anovia to begin. So whenever you are ready, Andrew, the floor is yours.
Great, and just a big thank you to Beth Talley and the entire CTO team for putting together such a great program. Hi everyone, I'm Andrew Lee, president and co-founder of Innovia Geo, And I'm here today to tell you how we're innovating heating and cooling from the ground up. Because for far too long, we've been heating and cooling our buildings and homes the same energy-intensive ways. We drill deep into the earth for fossil fuels and pipe it thousands of miles. We use power-hungry air conditioners, which are at their least efficient when we need them the most. And this all adds up to an enormous amount of energy and impact. In US households, for example, nearly 70% of the energy used is just for heating and cooling, and this needs to change. And finally, change is happening. Around the world, cities are taking notice and enacting policy to decarbonize our buildings and homes. In my hometown of Toronto, for example, all new buildings will need to be net zero by 2030. The question is, how do we do it? And the answer is sitting right beneath your feet. Geothermal systems provide renewable heating and cooling with zero direct emissions by using heat pumps to move heat between a building and the ground. The process operates the same way as an everyday air conditioner, but it's much more efficient because the ground temperature is stable compared to the outside air. In fact, you've used geothermal before if you've ever walked into a basement to cool off on a hot summer day. And because we're moving heat and not burning a fuel, it's incredibly efficient. So for every 1 unit of electricity used to run a system, you typically move 4 to 6 units of usable heating or cooling energy into a building. However, despite how efficient they are, very few buildings use geothermal, and this we want to change. And the main reason geothermal isn't more popular is because the conventional method to drill and install plastic pipes up to 600 feet into the ground is expensive, time-consuming, and messy. It's actually so messy that it made it on one of the episodes of Dirty Jobs. And to give a perspective on cost, for your typical house in North America, which requires a heating and cooling system about 3 to 5 tons in capacity, that means drilling for 1 to 3 days at a cost of $10,000 to $30,000. So why has this been the way to install geothermal for decades? Well, because it's a flexible drilling method that can get through most types of ground, even bedrock, and to reach 600 feet deep, you're going to eventually hit bedrock. But a simple question we asked ourselves was, do we really need to drill so deep? And the answer is no. The ground reaches a stable temperature all year round at only about 30 feet. And that's the key to the new approach we're taking at Innovia Geo, to focus on soft or shallow grounds to dramatically reduce the cost of installing a geothermal system. And we're doing this in 2 ways. First, our geopiles integrate geothermal functionality into steel foundation piles, so you can get your geothermal system directly from the foundation of your building. Second, our GeoWicks and GeoColumns repurpose soft ground construction techniques to install geothermal systems at incredibly fast speeds and with less mess. Compared to conventional geothermal drilling, our geopiles completely avoid the need to drill, and our GeoWicks and GeoColumns can be installed at rates of thousands of feet per day compared to hundreds of feet per day. And the goal of our technologies is to cut the cost of geothermal systems enough so that we can reduce the payback from greater than 10 years with conventional drilling methods to less than 5 years. By working with existing construction techniques, what we're physically doing isn't anything groundbreaking, no pun intended. What is new is understanding and predicting how heat gets transferred with shallower geothermal systems. To give perspective, using traditional simulation methods, it can take weeks just to analyze a single project. That's fine for a pilot, but it's not conducive to scaling. So we've developed an entirely new way to perform ground heat transfer simulations using AI. Our proprietary GPPS software platform allows us to cut the analysis time from weeks down to minutes. The beta version of our software is functional and allows us to conduct rapid simulations with our geopiles. Our software also forms a key part of our IP strategy because we've designed it to input real operating data to constantly retrain and improve the AI. By doing so, we'll be creating an ever-expanding data moat as more projects get deployed. Our target market are the HVAC systems in new buildings, a $26 billion per year opportunity in North America alone. With our 3 technologies, we're segmenting that market into suitable building types and ground conditions, which represent about a $4 billion per year share of this market. Now, the building industry is complex with lots of stakeholders. but it's something we know inside and out with my partner's 30+ years of experience in the sector. And that's why we're focusing on working with existing techniques and technologies, so we can use the existing value chain to quickly get our technologies to market with minimal investment. To do this, we're going to establish regional implementation partners who will be doing the actual work of installing our systems. As an example, the companies here are the partners for our home market of Ontario for geopiles. Our regional partners are also a marketing channel for us because they have existing relationships with property developers in their regions. We're also going to work with what we call geothermal utilities. These are companies that build and own geothermal systems as a third party and sell the use of that system to the building or homeowners through a long-term contract. Finally, we're going to connect directly with early adopters. These are developers we've identified that have a history of sustainable design practices. As an example, here's what our value proposition looks like for a large residential development in Toronto. Compared to a conventional HVAC system, geothermal cuts the building's total energy use in half and reduces CO2 emissions by 60%. And it does all this while saving $200,000 per year in energy costs. So it sounds like a no-brainer, right? Well, the additional cost to install a geothermal system using conventional drilling methods is about $2.5 million, resulting in a payback of over 12 years, which is not so great in the eyes of most developers. However, the target cost range for technologies aims to reduce the payback to be less than 5 years, so we can really make geothermal a no-brainer decision for developers. Our geopiles are the first of our technologies that's nearing commercial readiness. We've installed a full-scale pilot that's been heating and cooling a service building at a power station here in Ontario since February. We're working with a world-renowned researcher to help validate the system's performance, and we're also gathering valuable real-world operating data to validate and improve the AI in our GPPS software. Our plan over the next 3 years is to start generating revenues with our geopiles to develop a base revenue stream. We plan to continue developing our geocalls and geowicks through the same process as our geopiles, with the aim of having them commercial ready in less than 3 years. And finally, tying it all together is the continued expansion of our GPPS software platform. In the short term, we're going to start by providing design and implementation services as an on-ramp to start getting our technologies adopted and some revenues in the door. As our technologies become more accepted, we want to transition to offer turnkey systems so we can bring in higher value system sales-based revenues. Finally, our vision is to become a geothermal utility ourselves, so we can develop and own revenue-generating infrastructure assets, which opens the door to large-scale exits with utilities, pension funds, or an IPO. My partner and I have self-financed Innovia Geo to this stage, along with our ability to secure almost $500,000 so far in non-dilutive grant funding. To start our near-term growth plan, we're preparing to raise a seed round from accredited investors on the order of about $750,000, which we're working right now to supplement with the $250,000 research grant that we've applied for, progressing through the review process. With a combined 40+ years of experience in the renewable energy and construction sectors, our team has the experience and relationships to take Innovia Geo to the next stage. Over the next year, we plan to build out our senior management team to effectively execute our go-to-market strategy to achieve our goal, which is to accelerate geothermal energy for a cleaner and brighter future. Thank you.
Great presentation, Andrew. Judges, any questions?
There's some quiet.
Go ahead, Daniela.
Thanks.
Hi, Andrew. Thank you so much for the great presentation. Quick question, how does pricing and price point compare to traditional heat pumps?
Sure, so we're not doing anything new to the mechanical system. So we're using existing heat pumps. What we're modifying and changing is what's going into the ground. So with conventional geothermal systems, I'll just jump to this slide here, the typical cost to install the piping to the ground is about $3,500 to $7,500 per ton. This is North American pricing. And so our target range for our costs are to be $750 to $2,000 per ton with our technology. So looking to really cut in half or better.
Thank you.
So Alba, you're next.
Hi, Andrew. First of all, great visuals in the presentation. I loved it. And then my question is, are you only targeting new buildings, or are you going to also move to existing buildings? Because I saw in the presentation, you only mentioned new ones.
Yeah, new buildings is our current target. Retrofits are possible, but typically it's actually the mechanical system that takes the most investment to actually retrofit. So we can work with existing sort of mechanical systems as long as they can accept the geothermal system and connect with it. So as technologies evolve for building mechanical system retrofits, we can interact and work with those types of companies to implement and integrate geothermal into them.
Great, thank you.
Dan, you're next. Dan? Okay, Dan must have walked away. Brandon?
Yeah, what's the feedback, Andrew, from installers? They maybe get paid per foot. What's the adoption like on the design services so far?
Yeah, so we're, as opposed to working with the conventional geothermal drillers, we're actually working with foundation contractors and ground improvement contractors. So it actually opens the door up to larger projects because typically geothermal drillers are regional in nature, maybe own one or a couple of drill rigs. So definitely it's tougher for them to scale and get onto larger projects. So we found working with foundation contractors, ground improvement contractors, they actually have a lot more sort of muscle that they can bring to the table, and actually a lot of interest, because a lot of what they do isn't really considered sort of sustainable and green. So they've had a lot of good interest from our partners in wanting to work with what we're doing.
Jing, you have a question?
Yeah, I wonder, are you only targeting this geothermal piece for the contractor for new buildings? Do you provide them with maybe a more overall solutions? Because geothermal is such a small choice that they need to make for new construction, and also the people who are using the building are not the one constructing the building. So there is a misalignment in interest.
Sure. Yeah. So on your first question there, we're looking to sort of interact with the variety of people within the industry. We're looking to start with providing just the infrastructure in the ground. That way, we're just not having to do investments into designing full systems and building that capability up. Our plan is to transition to offer turnkey systems, once our technologies get more adopted and we're able to get that scale.
Great.
And then in terms of, okay.
You have 2 minutes to finish your scoring sheet. Next up, we will have Osmosis. So you are welcome to share your screen and test your audio.
Hello, audio check.
Yep, we can hear you.
That's great.
It looks like we've had a few new people join us, so I just wanted to let everybody know that we are currently in between presentations and we are just about to start our third presentation. Our fourth presentation. All right, judges, it's time for osmosis. I will hand it over to you, Francesco, whenever you are ready. The floor is yours.
Thank you so much. Thank you so much. Hello, everybody. We're Team Osmosis, and we are transforming the way chemical separations are performed. And why this is such an important thing is because 15% of the world energy is wasted on inefficient chemical separations. And 16% of the carbon emissions depends on the fact that we still rely on century-old technologies, like those that you can see on this slide, to perform these separations that are critical to enable the chemical and energy infrastructure. So these chemical and power plants are literally everywhere. This is just the United States, but it's really a global problem, which makes this one of the greatest challenges of these centuries, but also one of the biggest opportunities for companies like us that can bring innovation in this space. And really, the impact of separation is not just limited to the separation itself, because traditional separation processes are increasingly a bottleneck for clean energy solution to make it to the market and make a breakthrough. So coming up with new separation processes is really key to enable a sustainable future. In fact, at Osmosis, our mission is to eliminate the energy waste with efficient separation technology, in particular membrane technologies, reducing production costs for our customers and CO2 emissions for the environment. When you look at traditional separations, they are very effective, but at the same time, extremely inefficient. And this is because they require high energy, because they're mostly thermal processes when you really need to boil off components to get to the purity that the market needs. So membrane technologies really revolutionized the way this is performed, because they operate as molecular filters to separate molecules from one another. So if you consider this is our membrane and this is the molecules we're trying to separate, think of the molecular filter to separate them from one another. They have low energy consumption, but the problem with traditional membranes is their poor separation, which leads to very high operating costs and eventually lack of adoption that limits their impact. So at Osmosis, we came up with the material platforms that check all the boxes. We have low production cost, low energy consumption, and exceptional separations to make Osmosis membranes the clear solution for the future of separation. And in general, when you think about filters and membranes, really thinking about the scale that of the molecules that you're trying to separate is extremely important. So starting from the right, where molecules are very big, coffee filters, there is a problem that is solved. If you look to the left, you go down to water desalination. Those are all problems that have been addressed and made a breakthrough in the field, for instance, water desalination with membranes and reverse osmosis. But really where there's an unmet need today is with the smallest molecules, which are gas molecules. And this is really what our technology, which is a ladder polymer that when packed in space is extremely efficient, and the porosities resemble the dimensions of gas molecules, being able to separate them from one another in a way that is truly unprecedented. So if we look, for instance, at traditional and renewable natural gas treatment, where the molecules that you're trying to separate are CO2 and methane, and you identify the two key parameters for membranes, which are selectivity and permeability. High selectivity means low operating cost, which comes from energy saving and product recovery. High permeability, on the other hand, means lower capital cost, which comes from the fact that you can generate smaller separation units. Looking at traditional membranes, they have both low permeability and low selectivity, which leads to high operating cost and capital cost. New membranes from the literature, they really address the problem of permeability and flux, but really nobody were able to come to, bring both the performance together and really collocating materials to the top right corner, which is really where you want a technology to be to have a breakthrough. And that's where osmosis comes into place. We tested this membrane in industrially relevant conditions, and we had third-party validations. And we know that we can reduce methane loss up to 85%, which in other words means that you can save extra fuel to power 7 million additional houses in the United States for 1 year. And Osmosis overall addresses a huge market. This is a 10 billion and growing market. And we have three distinct phases. The first one is focusing on increasing sustainability of existing energy infrastructure. And you can think of traditional and renewable natural gas upgrading, which is a $5 billion market today. But really it's not just that, because just in this market, we can reduce carbon emission up to 100 million tons of CO2 per year. Then we can go into a second phase, which is decarbonizing new and existing industries. And by talking to customers, we learned that power generation, as well as glass, steel, aluminum industry, they're really looking for carbon capture powered by oxy-fuel combustion solutions. And this is something that we can offer. And eventually we really target to enable carbon-free energy solutions, which means, for instance, hydrogen recovery, which is one of the key markets we have clear value proposition for. So our product initially is going to be a compact membrane module. That is a key component of production platforms or power generation plants like the one that you see here on the left. And because our innovation is one of the layers that makes this compact membrane module performing the way it does, we fit into existing infrastructure because our technology can simply retrofit all the membrane modules that are already out there. And the point is that there's already 5 to 10% of the market that is using membrane technologies to perform this separation. So we can retrofit and fit into existing infrastructure because of that. This leads to fast adoption, creating an opportunity for a pay-as-you-go model. And through customer discoveries, again, we learned that this is great because one, they want to be alleviated from upfront cost. And second, they want to have a relationship with the company that provides these materials and these solutions. And we want as well to have that relationship to improve over time and understand better what value we can generate. So if you consider a standard customer, we can generate a value of $50 million reduction in operating costs and also eliminating 1 million tons of CO2 emission every year, which means the sustainability comes along with improved financial performance. And also for Osmosis, we can generate a revenue of more than $7 million for each of these customers every year. By looking at the financial and metrics, we've been able to identify an obtainable market, which is our beachhead, which is small US onshore gas processing companies. And this is almost $200 million per year. And on the left-hand side, you can see our revenue and total cost projection, which means that basically we can have a payback in around 2 years, around 50% margin, including install cost, and a positive earning by 2025. When you think about exit strategy, we are really inspired by other membrane startups that were acquired by established companies. In particular, we've been able to identify the two key parameters for that are market synergy, which means a growth opportunity for the company that is acquiring the startup, and strategic value that in most cases was membranes with increased performance were interesting for these companies. So the case of Nano H2O is very important for us because they founded in 2005 as a university spin-out, and they were acquired 9 years later for $200 million, really being part of that revolution in the reverse osmosis with membranes that happened during those years and made membranes leaders in the field with 80% of the market. So we think that we can do the same for gas separation in this space, in the space of membrane technologies. So now let's move to the team. Our team is extremely well positioned to meet the challenge from the molecular design to the industrial processes. My name is Francesco Benedetti, and I'm the CEO and in charge of strategy and funding, background in chemical engineering. And I'm joined today by Holden and Zach. Holden is our CTO, is a PhD in chemistry. And Zach is a professor at MIT and in charge of scientific innovation. And he has 15 years of experience in membrane technology. Catherine is also going to join us early next year, and she's going to be in charge of management and operations. We also have an incredible advisory board that we're going to announce very soon, and they're going to really complement our very technical skills with industry, sales, financial, really in the chemical and energy industry, but also experience with starting and growing companies and the customer relationships and sales. So we're very excited. And also I really want to acknowledge incredible summer interns that have been working with us throughout the summer and really helped us pushing forward the company and the deliverables of the Cleantech Open Accelerator, both for the business and the engineering. Thank you very much. And really to recap, we started with this idea in 2017, and we had a breakthrough achieving unprecedented performance at lab scale in 2019. We have patented our technology to own the innovation, and we validated interest of customers by interviewing more than hundreds of them. And recently, Holden and I won the Activate Fellowship, and also all together with the team, we won the MIT 100K competition. We are going to raise now a $2 to $3 million pre-seed round that is really going to enable us to scale up. In particular, we're thinking about manufacturing contracts. We're thinking about hiring extremely talented people in our team. So by the way, we're hiring, so please reach out. And really working on the business and the business for our technology and company. And eventually, this is going to help us building an industrial prototype module that together with grant revenues will allow us to sign MOU with customers, raise a seed round in a couple of years, and have our first revenue generating customer by 2024, 2025. So really Cleantech cannot wait anymore in the space of separation, and we're here to address this challenge. Thank you so much for listening, and looking forward to answer your questions.
Thank you, Francesco, for a great presentation. Judges, any questions?
All right, Dan is up with a question. Go, Dan.
Yeah, great presentation. Thank you so much. I'm just wondering, do you have any demonstration projects or partnerships yet to try out your technology in real life applications?
So we're actually working on the, so really part of the reasons why we're collecting, we're raising this pre-seed is to get to the point that we can test with pilots with our customers in industry. But now all the validations that we had in different labs around the world, and we're able to test a lab prototype for that.
Great. Daniela?
Hey, Francesco, congratulations on the breakthrough.
Thank you so much.
How long does a membrane last, and how often would you have to replace them?
So so I'm on the team as well with Osmosis. So we've tested these membranes in very extreme environments in terms of chemical to test for their chemical and mechanical stability. And so based on our experiments, we expect them to last about 3 to 5 years. In short, these membranes are designed to be very mechanically and chemically stable. So we've challenged them with very reactive chemicals in the lab, like hydrogen sulfide, for example.
Super, thank you.
Thank you.
Oops, I saw another hand and it flew by. Somebody has a question, go for it. One of the judges.
Hey, it's Brandon from EIF.
Thank you.
When you swap in your technology with the incumbents from, and swap it out, what are the other use is that would change, right? Be it upfront costs, maintenance. Can you explain what the customer would have to change in their behavior with this technology?
Yeah, so with existing membranes, you have to replace them every few years anyway, because membrane wear out over time. So, in replacing existing membranes with osmosis membranes rather than traditional membranes that are less efficient at separation, that's not going to introduce any new costs to customers that they don't already have. So that's why we're very interested in doing this drop-in replacement, because that would allow for a fast market adoption.
So Jane, question?
Yeah, so can you tell me how are you projecting, $7 million per year from one customer? In a sense, it's also like, it feels like they all need a membrane change every few years.
So sorry, could you repeat that question?
Oh, maybe I can get that.
Oh,
so
yeah,
what we're thinking is really a subscription model, charging basically $20,000 per day. And this is kind of really where the math adds up, considering our margin, considering our cost of production, but also the value that we generate for the customer. And really that allows us to achieve a margin that is around 50%. So it's a continuous revenue generation. And that $7 million is really what we can get every year with a customer. There is a pretty big size customer. So that was really to get around the number, around that specific customer, but each of them is different size. So depending on the size of the customer, we're gonna have different revenue and of course, different operating cost reductions.
Thank you, judges. You have 2 minutes to finish your scoring sheet. Next up, we have Princeton New Energy. Chow, if you would like to practice sharing your screen and making sure your audio is good, feel free.
Thank you for all the questions and for everybody to be here.
All right, thanks, Beth. Let me share my screen.
We can see your screen and you came through loud and clear.
All right, thank you.
All right, judges, it is time for Princeton New Energy. So whenever you are ready, the floor is yours, Chow.
All right, thank you so much. So good afternoon and good evening, everyone. My name is Chao Yan, and I'm the CEO and also the founder for the Princeton New Energy. So PNE provide a novel plasma-based lithium-ion battery recycling solution to recycle the waste lithium-ion batteries and also the manufacturing scrap from the lithium-ion batteries. So recycled materials, for example, cathode and anode materials, gonna sell back to the supply chain to support lithium-ion battery market and also EV market. So there's three major gaps that the PNE gonna fill in the future. So the first one is due to the fast growing of the EV market. There's a huge demand for the lithium-ion battery manufacturing. Therefore, there's about 5 to 10% manufacturing scrap about the during the fabrications. Therefore, PNE are able to recycle such manufacturing scrap from the lithium-ion battery and to support the materials. And the second, the gap that PNE gonna fill is that due to the fast growing and the demand for the lithium batteries, the strategic materials are the key things to make the electrification shift successfully. Therefore, PNE are able to recycle such materials and support the EV markets. And the third thing is that we know the lithium battery has a lifetime about 5 to 10 years. So after that time, all the battery will become the waste. So PNE will recycle such waste lithium batteries, and also during the recycling process, we are not produce additional waste. So here's some numbers I want to show to us. From right-hand side, you can see the electrical vehicles in 2020, the cell number is 2 million. And this number gonna increase to 26 million in 2030s, which is very fast growing. And this drove the lithium-ion battery demand from 220 gigawatt hours in 2020. And this number gonna reach to 2,500 gigawatt hours in 2030s. And there will be tremendous manufacturing scraps need to be recycled. And from end-of-life lithium batteries in 2020, there's about 465,000 tons of lithium batteries, and this number can increase to 2,600,000 of tons lithium battery need to be recycled. So PNE provide a sustainable, non-pyro, non-acid leaching recycling solutions. So for our technology, again, we are sustainable recycling solutions. There's a non-pyro, no acid leaching solutions. We don't provide a gas and the liquid emission during this process. And also we have a major reduction of the water and energy usage. And on top of the sustainability, we also can have a huge cost reduction for the lithium-ion battery recycling operation. And we do have 3 pending patents to protect our technology, and also with several trade secrets. And today we are in the technology readiness level 7 in progress together with Wistron. And the first pilot production line will be ready by the first quarter 2022. So here are some number I want to share with you about our pilot line. So we are able to reduce 80% of CO2 greenhouse gas emissions and 70% of water usage and 80% of energy usage. And again, zero gas and the liquid waste. So if you compare with the traditional mining or hydro is acid leaching solution or PNE solution, you can see for the CO2 footprint, mining will generate 22 kilograms per kilograms of cathode produced, and hydro is 13 kilograms. PNE only emit 4 kilograms for the CO2 emissions. And for the water usage, mining need to have 25 gallons, and hydro is 16 gallons, and PNE only have 7 gallons. So there's a huge the waste reduction. And also, on top of the sustainability, we need to make our business profitable. So PNE provides 3 business models. And the first 2 business models in short term are ongoing business model. The first one is equipment licensing. Second one is the total solution as a services. We combine these 2 business models to work with our partnership, Wistron, to kick off our pilot production line. And assume the pilot production goes smoothly in the future 6 to 12 months, and we're gonna joint venture with Wistron and other potential partners to kick out our manufacturing business model. And during here, we will recycle the waste lithium battery and sell the recycled materials. And then this is a high revenue business. And here I want to share with you our ecosystem and also our joint pilot partnership. So today, PNE is partnered with Wistron and ETEC, and we will build the pilot production line in Dallas, Texas. And I want to show you here, so we are not only recycle the electronic devices battery from Apple, HP, Samsung, Dell, or something like company like this, but we are also able to recycle the batteries for the EV market. For example, from Panasonic, Tesla, LG, Ken, Ford, all the type of the company, we can recycle them. And assume the pilot line goes smoothly in 2022, and then we're gonna join a venture with Wistron and to increase our recycling capacity and continually to recycle the battery materials. As you can see on the left-hand side, I'm showing in the base case, in the 2025, we are able to reach to 30,000 capacity to recycle the lithium batteries. And this is gonna give us about 300 million revenue by 2025. And in order to support this business, this financial forecast, we do have an experienced management team, and we have a 10-person team with comprehensive battery research and also industrial knowledge. And this is gonna support us for the pilot production line with Wistron in the first quarter 2022. And on top of the management team, we do have very strong advisory board team. So we are combining the technical advisors from Princeton University, UC Irvine, Brookhaven National Labs, and also the financial advisor from former Goldman Sachs, and the strategic advisor from former Accenture. So all of us to build our technology, to file our IP and to protect our IP, and also to run the business development to sign a contract with our partnerships. And the last, we go to the final slides, which is the roadmaps and the milestones. From the first line, you can see since 2019, PNE was founded, and we get over 1.4 million grants from Department of Energy, and also NJEDA, and also Princeton University, National Science Foundations. So all of these grants help us to build our technology and to file IP and to make this IP landscape is well protected. And on top of this, we do have angel round investment to help us on the business development. So we are able to reaching out to so many potential customer, for example, like Wistron and the electronic devices company and the EV companies. and help us. Most important thing is to sign agreement with Wistron to kick out our joint pellet production line in Dallas. And the next step, we're gonna raise Series C round investment for $5 million. And this is gonna support us on major two things. The first one is to continue to build our leaderships. And this, we're gonna involve the auto vehicles companies. We need more talent from EV companies to support us and to secure the future supply chain for the waste batteries. And the second thing, this Series C round investment can help us to support joint pilot project execution and also the operation. And today we are in the technology readiness level 7 in progress with Wistron together. And after this period, we're gonna reach to level 8 and level 9. So that means after this period, our technology will be ready for the commercialization and also scale up. And to talk about exit strategy, as the right-hand side, you can see. So we are able to merge an acquisition together with Wistron, which is our current partnership. And also there's so many big players in the EV market and also battery market, like Tesla, Panasonic. We are able to discuss with them and to move forward for the acquisition. On the other hand, we are, as our recycling capacity increase and the revenue increase, we also has opportunity to go SPAC or to go IPO by ourselves. And thank you so much for everyone's attention, and a happy answer to all the questions.
Great. Thank you, Chao, for a great presentation. Judges, any questions?
Okay, who has a question here? Adam.
So I think the business model, if I got it, was to take the waste and reconstitute cathode or anode. Is that correct?
Yes, we're gonna take the waste battery and to get a cathode and anode back out from the waste battery and support back to the supply chain.
So then how does that work with the future chemistry changes with battery chemistries? When you recycle one and the chemistry changes?
I think this is a great question. So typically the materials continuous increase, but it still needs some time. So for example, for the electronic devices battery, they're using the LCO materials for many years. So we are able to sell them back. And then for the EV market batteries, is still have some time period. So we are able to sell them back, yeah. And the most important thing is for the manufacturing scrap, that's directly we'll give back to them.
Thank you. Nika, you're next.
Yeah, so another question around the business model. Did I understand that you were doing some packages of second life batteries as well?
Yeah, no, actually for that, we are not working on the second life directly.
You're not working on the second life directly. Okay, thank you.
Yeah, thanks.
And Dan?
Yeah, I was just wondering a little bit more detail on the technology. It looked like it was potentially plasma. So that's typically high energy intensity. So like, how do you consider your cost of production versus conventional hydro or pyro? And also again, several new players like Encycle or battery resourcers or even Li-Cycle.
Yep, thanks, Dan. This is very good questions. So basically for the plasma it's true, it is energy intensive, but plasma is just a small portion of my entire process. And also plasma process is a high throughput process. So all the cathode materials only stay in the plasma area for a few seconds. Therefore, for this step, we are not a high energy intensive step. And if you compare with the traditional hydro and a pyro, and we do a carefully life cycle analysis, we have a huge the energy reduction comparison. I can bring you more details maybe from later. Yeah.
And Alba, you have a question?
Yes, first question. First of all, thank you for the presentation, Chao. And basically, I wanted to know, how do you differentiate yourself from the competitors? Because recycling batteries is a very crowded space.
Yeah, Thanks, Alba. This is also great questions. So we differentiate myself with other people from technology. So traditional is hydro and pyro technology, which using the high temperature or the acid leaching. They will provide a lot of the waste during recycling. And our plasma technology is much more cleaner than them. And also due to the cost of reduction, we are much more competitive compared with them.
Thank you, judges. You have 2 minutes to finish your scoring sheet. And next up, we have Stack Technology. So you can begin sharing your screen and practicing audio.
Thanks, Teddy. Thanks, everyone.
Thanks, Cha. We can see your screen. And Bobby, do you want to say something?
Sure. Can you hear me?
I can. Thank you.
That's great. Thanks.
Yep. All right, judges, it's time for Bobby of Stack Technology. So whenever you are ready, Bobby, the floor is yours.
Excellent. Thank you. I'm here with my colleague, Paul Christofferson, and thank you for the opportunity. So we are Stack Technology. Our mission is to decarbonize cooling. As a deeply experienced team, we are united in our common passion towards commercializing hardware technology and in our comprehension of the scale of the problem we seek to solve. And there is a big problem when it comes to the future of space cooling. We've all likely seen buildings that resemble the image you see here. This form of space cooling is high energy and emissions intensive. It represents a critical blind spot to global sustainability. The huge amount of growth in high energy cooling over the next 30 years will kickstart a vicious cycle that will contribute a significant share of total greenhouse gas emissions by 2050. Left unchecked, it will alone contribute 0.5 degrees Celsius in global warming by the end of the century. What is needed is a technology that can help break this cycle. We believe we have a solution. Our in-house invented and developed low energy cooling system is unique to any conventionally available chiller in the market today. As a system capable of being retrofitted into existing infrastructure, its novel architecture and protected process, as illustrated here, provide 3 critical improvements over conventional systems. First, an advanced turbocompressor lowers energy consumption by 40%. Second, it eliminates the need to employ harmful refrigerants. Lastly, it produces a unique and especially capable ice slurry medium that has 7 times the cooling capacity of chilled water. And our solution is real. Following on from the successful operation of 2 prototype units, one of which ran continuously for 10 years, we have de-risked the technology and advanced it into the 21st century. Our latest Model 1 pilot unit is targeted to be commercially available in the second half of 2022. At 300 kilowatts of output, a single Model 1 system will be able to cool 40,000 square feet, which is similar to the scale of the building shown here. But individual buildings are not necessarily our primary target market, as they exist in a fragmented ecosystem. For context, the cooling market can be divided into 3 segments: room, building, and district scale. We believe that district scale networks represent the optimal segment to target because they best fit our need to pilot, install, and scale our technology. Once we break into the market with a proven solution that can solve key challenges, the ecosystem is approachable, tight-knit, and favorable to allow for rapid scaling. We identify district networks as our target market, and that really excites us because they represent a significant share of worldwide cooling and are gaining market share as the fastest growing subsegment. In addition to the growth, customers are expert hardware integrators, welcoming diverse technical solutions to retrofit existing networks. They often operate tens to hundreds of networks, lowering repeat customer acquisition costs. They share a common strategy to lower energy consumption and overall greenhouse gas emissions. They purchase hardware based on total cost of ownership, and they seek out external innovation and are willing to co-develop technology solutions. To illustrate this market's opportunity, the chart on the left shows the geographic distribution of installed district network chiller systems in operation today. The table on the right highlights an approximate annual spend of $2 billion on nearly 2,300 chiller systems purchased by district networks this year. We assume a 5% upgrade cycle and 9% annual growth in new networks, but believe these factors could prove to be conservative for two reasons. The first is that when the rapid payback economics of our system are confirmed, we believe that the operators of the nearly 17,000 installed chillers will seek out retrofit using our solution. In addition, the implication of the US's American Innovation and Manufacturing Act, in concert with other global protocols, all but assure a bow wave of replacements as legacy fluorinated chiller systems become non-compliant with new regulations being enacted this decade. In this vein, our sales growth will not be limited to mere market growth plus upgrades. Growth will only be limited by our own ability to close deals and deliver product. STACK's advantages will warrant the accelerated displacement and conversion of the global install base of legacy chillers and district networks, a $15 billion opportunity today. Once technically validated and certified, we believe our chiller system can take a meaningful share of the serviceable annual market. The figures at the bottom present a high-level financial summary for our baseline go-to-market scenario. Direct sales of STACK chiller systems at $900,000 each that are self-produced for approximate cost of goods sold at $520,000 each, realizing a 41% gross margin. Via bottoms-up analysis of our customers' needs and an assessment of our future manufacturing capability, we believe we can deliver 162 units in 2026, realizing 5% share. Critically, though, our commercialization strategy is to disrupt the industry and raise the efficiency standard for all chillers globally. To do this, we will seek to partner with an established OEM. This strategy will enable rapid scale, will fund our own bandwidth to further develop the technology into adjacent markets, and offer an exit pathway for early investors to realize a return. And we believe that taking the 5% share in 5 years is achievable because our solution solves critical pain points expressed to us directly by customers. Lowering energy consumption by 40%, in addition to other operational cost savings related to using water as the refrigerant, will enable a customer to pay back the incremental investment made in a STACK chiller system within 2 to 4 years. This is incredibly exciting. For equipment expected to run for 20, this will be the major selling point to drive rapid adoption. Corporations and building owners are increasingly being held to account for reducing emissions. Our system will enable a step change in improvement, reducing emissions by 5.5 tons of CO2 annually versus the conventional chiller that it replaces. This level of emissions reduction potential compounds in impact as you scale from a single unit to 50% share of expected chiller sales, and then to total conversion of the global installed fleet at nearly 2.6 gigatons of avoided emissions over 20 years. District networks also encounter numerous challenges related to the operational complexities of handling, storing, and using conventional refrigerants that our solution can immediately resolve. Our system improves cooling efficiency by continuously producing ice slurry, eliminates the burdensome controls needed to monitor and contain refrigerant leaks, and reduces system incompatibilities related to the corrosive properties of refrigerants. When we look at the capability of the market today, we see an especially dense field of established competitors. We differentiate ourselves from this field by being the only company able to deliver a physical system that could set a new standard in low energy cooling. What is common amongst our direct competitors is their large installation base and their mature supply chain, manufacturing, sales, and distribution networks. We believe this common characteristic amongst our competitors will give us an adequate pipeline of potential partners with whom we could rapidly scale and deploy our technology. And potential partners, customers, and competitors alike are interested because very little has changed in the refrigeration industry since vapor compression systems became the standard in the 20th century. Illustrated here, Stack's system can outperform conventional chillers today, and with accelerated development, we can quickly widen the advantage. We have had numerous discussions with prospective partners who express explicit interest in the capability of our technology and its potential to disrupt the market. We have a capable, passionate, and experienced team and advisory board leading our efforts to recruit experienced contributors and executors in order to scale our business. Gunnar is our inspiration, as our story is centered on bringing to market his life's work in pioneering heat pump and refrigeration technology using water as refrigerant. We are taking action, though, against a plan to fill critical resource gaps, especially in engineering, program management, and business development. Our vision is to make an advanced 2 megawatt water as refrigerant solution tailored to the needs of district networks globally available by 2024. In order to achieve this vision, we must act now. We have de-risked our solution by basing it upon a successful 2 megawatt installation that proved the feasibility and advantages of a scaled water as refrigerant cooling solution. We have bootstrapped the invention, development, and protection of our 300 kilowatt Model 1 system that can serve to fund our working capital expansion on deposits from systems being sold starting in late 2022. We seek financial partnership to accelerate the development of our advanced 2 megawatt Model 2 solution. At an assessed total development cost of $16 million, we have the opportunity to disrupt a $21 billion market by 2026. We choose to accelerate the development by seeking financial partnership because the market is hungry, cooling is an essential need, and our climate cannot wait. Thank you.
Thank you, Bobby, for a great presentation. Judges, any questions?
All right, it looks like NECA is first. Go for it, NECA.
Thanks, Bobby, for your presentation. When you're talking about district level heating and cooling, there are so many stakeholders. You talked about working with the network operators, but can you talk about the switching costs associated with changing over to the Stack technology?
Yeah, there certainly are switching costs. We think that those switching costs are going to lower over time as carbon becomes more expensive, and also really because there's quite a bit of pressure on these companies to maximize their own potential against reducing carbon emissions. So we do feel as though we have some tailwinds there. I think when we are looking to pilot our system, we're looking to adopt it into an existing retrofit network. So it's a good case study for us to get a sense of how much the appetite is for us to place these systems and overcome that barrier of switching costs.
Thank you.
Thank you. Any other questions from the judges? Okay, Brandon, you're on.
Yeah, to piggyback on the switching cost question, do you consider your technology an all or nothing proposition, right? How will you educate the market on the value that you anticipate without forcing them to put all their eggs in your basket?
It's a good point. This technology, we've had discussions with some engineering consultants last week, for instance, and their comment was, it's not new technology, you're just doing it in a different way. And so I think with Gunnar's experience in doing this back in as early as the 1990s, really, and now we're advancing it to where we are today, I do think that there's an educational element, but a lot of the thermodynamics that underpin what our system can do based on the use of this turbo compression system, it will resound, I think, with the people who are making purchasing decisions in these networks. So I do think that there's some evangelist work that we have to do to get our message out. But I think the principles upon which the technology reside will help us to overcome that all or nothing perception. Because it is modular, it should be fitted into networks, and water as a refrigerant is common, it's ubiquitous, so it's easier to implement than possibly in the future a synthetic refrigerant type system.
Any other questions from the judges?
All right, thank you, judges. You have a couple minutes to finish your scoring sheet. And next up, we have our poll, our People's Choice poll. So I will go ahead and set that up. So feel free to vote for your favorite, and it is live. We are at 14 seconds left. All right, our poll is over, and I will hand it back to Beth.
Unless you want to tell us who won the People's Choice Award.
I can do that. Our winner is Innovia Geothermal.
Congratulations, Innovia. You got the People's Choice Award. That's awesome. So we will have a judging deliberation after this, and we will determine who the other winners are. But congratulations to Innovia Geo and to all of them. All of the startups who pitched today, you all were terrific. It was really, really great to see your stories. I'm just going to let you all know that we will be posting the results on social media, on our website, and so stay tuned. Tomorrow we will let everybody know about that. But I did want to just take a moment to thank the Cleantech Open Northeast team, Tally Kane, Northeast Program Manager, and Phoebe Sue, Innovation Intern, are doing a great job keeping everything going here. And thank you very, very much. Thank you to all of our esteemed judges and our judging committee. Thank you to our mentors who make Cleantech Open strong. Thank you to our sponsors who make everything we do possible. And most of all, thank you to the startups for inspiring us every day with your brilliant ideas, hard work, perseverance, openness, and appreciation for what we do. You are why we're here. Congratulations to the Cleantech Open Northeast class of 2021. You give us hope for the future of our planet. The IPCC report sums it up well. It is, and I quote, "It is unequivocal that human influence has warmed the atmosphere, ocean, and land. Widespread and rapid changes in the atmosphere, ocean, cryosphere, and biosphere have occurred. Global surface temperature will continue to increase until at least the mid-century under all emission scenarios considered. Global warming of 1.5 degrees C and 2 degrees C will be exceeded during the 21st century unless deep reductions in carbon dioxide and other greenhouse gas emissions occur in the coming decades. From a physical science perspective, limiting human-induced global warming to a specific level requires limiting cumulative CO2 emissions, reaching at least net zero CO2 emissions, along with strong reductions in other greenhouse gas emissions. Strong, rapid, and sustained reductions in CH4 emissions will also limit the warming effect resulting from declining aerosol pollution and would improve air quality. We must find and implement solutions rapidly. Cleantech Open is focused on training clean tech and climate tech entrepreneurs with promising innovations that can be commercialized. Our startups are making great progress, but more needs to be done, and fast. So we just heard about 6 fabulous solutions: sensors to produce actionable sustainability and ESG data, accessible geothermal power, improved air ventilation, carbon capture through chemical separation, lithium-ion battery recycling, and water vapor-driven turbo compressors for heating and cooling. These are very smart solutions. And these are just some of the ideas that the 2021 cohort is working on to reduce emissions and create more green jobs. I can't wait to see what you all do. There are lots of ways to get involved. Participate as a startup, mentor, judge, coach, partner, sponsor. We're happy to explore possibilities. We want to do more, and we welcome you. Thank you very much. So to celebrate the accomplishments of the startups, we encourage you to unmute, turn off your video, and applaud the 2021 Cleantech Open Northeast Regional finalists. And I also want to thank the judges. You were terrific. Really great to hear your questions, and thank you for being so attentive to all of the details that the startups were presenting today. That concludes our program for today. And if you'd like to know more about Cleantech Open, feel free to reach out to us. We will stay on for maybe another minute, I guess. And if anyone wants to put any notes in the chat, we can stick around for a moment, and then the judges will go on to the next meeting to deliberate. So thank you, everybody.
Thank you, Beth.
Absolutely. Sure. Hi, Dave. Hi, Vicky.
Good job, speakers.
Hey.
Congratulations.